Hello and welcome to everybody who's joining us today. So 12 o'clock, I'm Tim Robinson, Editor-in-Chief of Aerospace magazine at the Royal Aeronautical Society. And I'm delighted to be this moderator for this webinar taking us through the results of a fascinating survey on advanced manufacturing in the aerospace sector. That was conducted by the Royal Aeronautical Society in partnership with digital design and manufacturing specialist Protolabs. I'm really looking forward to discussing the latest trends, technology, and the future of advanced manufacturing with a very distinguished and knowledgeable group of experts in this field. So a big welcome to our expert panel who are joining us today virtually to discuss the results and tease out some more insights for aerospace manufacturing for 2024. So joining me is Tassos Pantelis, who is European Project Engineer at Protolabs. We have Alex Hickson, Head of Technology, Structures, Manufacturing Materials at the Aerospace Technology Institute. Colin Mitchell, Head of Future Industrial Systems at Airbus. And Dr. Evren Yasser, Head of Additive Manufacturing, Advanced Manufacturing Research Centre. So welcome all. Great to have you with us. But first off, a few thoughts from Tassos summarising this year's survey before we get on to the Q&A. And I'd also like to remind people this is an interactive session and questions are very welcome. So pop them in the Q&A. There is a Q&A bar there in Teams. No guarantee that we'll get through all of them. But we will try and get as many as possible. So over to you, Tassos. What have you learned from this year?
Thank you, Tim. And from my side, hello to everyone and welcome to this really interesting session. So basically, this year we just revisited last year opportunity to see our findings with regards to the specific questions we conducted within the aerospace industry, and to see how these were changed, adjusted, or we would be able to learn even more about what would be thought to be the future of aerospace industry. There are quite interesting approaches, quite interesting questions also, as well as answers. But in order to make it short and to get the full value out of this discussion, we will just focus on each of the questions. We'll have some interesting replies and discussion among us. But of course, as Tim has already mentioned, please do note down some questions, because it will be a really nice wrap up at the end in order to utilize our time as best as possible, and of course have plenty of things to go through. So the main questions still remained the same. So starting, for example, about the key factors when designing and manufacturing for the industry. These are quite interesting answers again, because of course quality comes always first, but there is a really significant first place for this value, and of course this it has a lot of things to consider around that behind the section, which of course is followed by cost, which, as we can see in the times that we live these last few years, it is really depending on some social events as well as some market trends. So the main thing also that we need to consider would be the challenges that we would face within the aerospace industry in order to adopt the digital manufacturing. And as Protolabs has digital manufacturing, we can see some trends, and then we can adjust accordingly in order to satisfy the needs of the market. The project cost, of course, again comes at the high place, and as well as the expertise levels and the overall skill set that would be that they are available. And these are the top two ones to consider. And basically, the important factors that, like last year, which are the sustainability, which really was on a quite high percentage of the answers as a a key area to start with, followed by the skilled personnel. The actual supply chain shortages were a bit lower this time, as at the level of importance, and only because it seems that it gets into a better flow now compared to as it was a few years back. So it seems that this could be slowly going into the right direction. With regards to the next few questions about the key areas for manufacturing and for the manufacturing technologies, there is still something going around the robotic manufacturing, which is one of the highlights, which was significantly increased compared to last year's survey, and of course additive manufacturing at its as a whole. The more established processes like CNC machining and injection molding still they have a high trend and the quite constant values, slightly changed from last year. And basically the main question, to summarize everything, would be where this industry is heading to. So new technologies and sustainability would be also where on the top place, and we could certainly go through all these areas of these questions in order to justify these answers in a way, or make sure that everything is more transparent by giving some examples of each one of these questions, of these answers, in order to see and understand where we're heading. So we can start slowly with some discussion about certain areas and to see where we will head to.
Brilliant. Okay. Well, thanks for that. That's a great sort of scene setter. So we had about 10 questions in the survey. So we did it in 2023. Come back in 2024, most of the same questions. We did add one on AI, which I think we'll get to at some point. So I'm going to take moderator's privilege and start it off and say, so that the main focus from 2023 has shifted to sustainability from recruiting more skilled personnel. So my question is, does that mean that the aerospace industry has solved its skills shortage, at least in the short term? Who would like to tackle that? Colin, you work for a big OEM that builds lots of airliners. Are we through the skill shortage now?
I say we're in transition to a different skill set. So from the legacy programs we've had, and obviously Airbus are now on the journey to a fully sustainable future for flight. That means we have a transition in our skill sets within the organization. So finding those people is a completely different challenge to what we have. There's a limited market for those people. The academic sector is still building the courses that will generate the people of the future. So I think we are challenged to find the right people to do specific skills. There was a period over the last few decades where there weren't the level of recruitment, and now we're seeing, as for myself as well, we're seeing a lot of people starting to go through the process of retirement, and we have that gap in the people coming through. So we have a gap in the 40 to 50-year-old people within the organization, which is leading to some risk of loss of skills. So the knowledge transfer is something that we're really focusing on as well. So I think we are focusing on the skills development and skills and recruitment. Yeah, I think it's going to be a challenge the next 5-10 years with those sort of topics.
Okay, Alex and everyone, are you hearing the same thing from your perspective?
I can comment on additive manufacturing aspects actually. So in aerospace, we still think additive manufacturing is an area where we have like shortages in terms of skills, and especially like the job vacancies has been like growing all over, like in Europe and in America and globally. So we need more people in additive manufacturing, and we are short of skills there. And also the volatility of AM people is quite high. So it's like 1 out of 3 people in additive manufacturing changes job every year. So it's quite difficult to find the right people, and also the need for skilled people is increasing. And also, if you look at the results, it's still the second item, the main focus for the aerospace. So maybe the first one is shifted to sustainability, but I think it's still there. It's not moved completely.
Alex, anything from you?
Yeah.
Or
Yeah, I agree. It's diversity of skills. There's so many new technologies that are required to be developed for these future aircraft, whether it be the ultra efficient aircraft or zero emission platforms. There are courses that are being put on by the academic institutions, by the RTOs that are helping obviously support that knowledge uptake, and recognizing that skills and capabilities that may exist in other sectors as well, to help support that. But the level of demand and activity in that space means that that there is a skills shortage, as the demand means that there just aren't enough people to deliver all of the sort of the R&D that's going on at the moment, and they're looking at the sort of the infrastructure and capability, the demand level for future fuels as well. So it is a gap, but it's also working with academia through things like UK ARC, RTOs, HVMC, to sort of map what the skills are, linking with the AGP skills group to make sure that the needs of the sector are properly mapped out, and then the supporting activities to make sure that people are coming through with those appropriate skills.
Okay, so staying on the topic of additive manufacturing, one of the things that jumped out to me at least, was key prototype manufacturing technology saw 74% pick 3D printing this year. So that racing into the lead. So how do we account for this? Has this been a breakthrough in technology in the past year, just more awareness, or what? So I think that's probably Evren or Tassos who want to maybe take a stab at that first.
Sure. Yes, I would just comment just only very quickly on the previous question about the skill set. Basically, it's something that we would need. It will take some time. It's something that it cannot be solved in 1 or 2 years, for example. So the very first thing is just to identify the needs, which I believe this is the stage that we are now. And from our perspective as digital manufacturer, we just able to see also from one angle what could be needed, and of course be able to support on that. Following the next question, basically, since additive manufacturing becomes more mature year by year, and of course depending on the industry, and speaking now for the aerospace industry, we're able to identify and focus on certain technologies, and combining the material science, we would be able to work with certain printing techniques, for example, in this case, because it's not only the manufacture of things, it's basically the material science and the materials that will be used and need to be used in the aerospace sector in order to further improve, adjust and expand the key technologies that can be used for this sector. So it is a combination of parameters, but I believe that yearly we learn more and more, and along with other parameters like, let's say, certifications, we would be able to go further down and in the right direction more precisely.
Okay, and Evren, what about you?
Yes, I can go next. So I think this question is answered more from a prototyping perspective rather than manufacturing. So I think, yes, additive manufacturing or 3D printing is, I think, increased in terms of awareness in aerospace. Companies use it as a manufacturing route as well because of its advantages like higher design complexity, reduced time to market, waste reduction. But still, in most of the cases, it's to test the first part or to reduce the time from design to testing. So I would say I think the answer to this question, like 74%, like on 3D printing, I think it's more coming from prototyping aspects. But of course, the IM technologies are becoming more mature, and new technologies, new processes are more explored in aerospace. But yes, I would say still we are not there yet to completely eliminate the other processes, and it's not the target anyway. So it's a process, it's a group of processes that will enable the design complexity that's not possible with other conventional techniques.
Yeah, so funny enough, we have a question here from the audience that sort of relates to this, which is we've seen 3D printing marked at 74%. So approval for flight has been a bottleneck here. Do we have trust that this will replace traditional casting and milling processes? And that ties in with something I've got here about a kind of a question there as how far away are we from 3D printing, additive manufacturing going fully mainstream? I mean, I've seen some big components done as sort of pilot projects, but it always seems to be about kind of 5 years away so far. So thoughts on that from the panel?
Maybe if I add on this, it's something that we've heard from a lot of our stakeholders across the sector that there are a number of barriers to getting the technology flying, and we recognise actually we needed to create a group that got people openly talking about this, and then how do you get the sector working together to come up with the routes to getting the technology flying. So we create an additive manufacturing community of practice that has a number of people from OEMs, tier one, supply chain, and industry experts, including RTO academia, to sort of define what the barriers were and what the routes are going and addressing that. So working with the HMC, there's a roadmap which will be published and launched soon, which helps provide that clarity, the stepping stones of what we need to do, because very conscious that a lot of money has been invested through the ATI program and more broadly across the UK and in AM, and I don't be sitting here in 10 years of going, well, it's another 5 years away after a huge amount of investment. But you've got to do that, bringing industry with you and working collectively on the right things in the right priority order that are going to go and address it. So we feel that is an effective route to go in doing that. Also lessons learned from other sectors where other materials such as composites, there are standards and routes to going and doing that, but it's not an individual part qualification. There's a known understanding of the materials and process, and recognizing also that there's an awful lot of costs associated with making it, with qualifying these materials. So how do you move to them? That's what more of a virtual qualification. So there's a number of activities that are supporting that, and we welcome when this comes out a broader feed from those across the sector, on that and what else they think that we should be doing. Obviously, ATI is there also to fund gaps in the R&T to move it forwards, but it's not just about the R&T. You've got to have the standards in place and everyone working on the right things. So that's a view of the ATI I'm sharing.
Okay. So moving on to the next question, I would say the skills crisis has been one shortage that the aerospace industry has been grappling with, at the moment. The other one has been supply chain shortages, just getting spare parts, getting components, the knock-on and kind of from COVID. And from disrupted supply chains around the world, but supply chains shortages dropped around 20% in a priority from 2023 to 2024. I mean, does that mean the aerospace industry is now past the worst, or if not, why not? Colin, do you have a view on this?
Yeah, I should definitely go first on this one. I would say, yeah, that's not our feeling. Okay, so the supply chain is still really, really struggling with ramp up. The market for aircraft is fantastic. Everyone is flying again, which is great. We can't build enough aircraft. It's as simple as that. We would love to ramp up quicker and deliver more aircraft, but for a number of different areas, which include the supply chain's ability to ramp up as well, we're not seeing that. So yeah, it's really challenging. I think the supply chain is creaking in many areas. and we're obviously supporting those companies where we can. But yeah, we don't really see things improving yet. It is in some areas, but other areas still, and you're controlled by your worst supplier, not your worst supplier, but the ability for them to deliver parts often. So yeah, not seeing it at the moment. Super levels of improvement, but hopefully that will come.
I mean, just on that point, and maybe thinking about AM as well. Is there anything that AM can do for this sort of supply chain shortages? I mean, if you're there stuck there for a plastic widget, non-flight critical, but you need it, and you're there,
Yeah, I mean, if they were all plastic widgets, non-critical, that'd be great, because then we could use AM. But often they're not. They're not those, and it's quite interesting. Almost linking to the previous question on that. If there was a mainstream, mature industrial process, qualified process for AM parts, I think we would be really, really interested in it. We're spending a lot of money developing the technologies internally. The development curve for AM just keeps growing. The machines, equipment, processes are all changing. There's hundreds of different options of different systems you can use. So having that instability in the development means it's very difficult to transition to, right, we're going to go and make all these parts, rate 80 per month, whatever, because in 2 months' time those machines might be obsolete, or there's a better one coming along. Plus in AM, you've got all the hidden costs around that. So designing for the build and the support structure around it, it's quite a high-skilled element. The part removal after the process, the management of the stresses during the cool down, the inspection. There's all these additional costs. So if we could find an economic process for AM that we could then apply, I think it would be fantastic, because obviously with AM processes, we can unconstrain the manufacturing versus design process much more, bring function into structural parts, so systems function into structural parts and vice versa. So yeah, I think that will come, but I still think it's at least 5 years off.
So there's a question here from the audience again. What are the barriers that are coming in between those supply chain issues? Anyone apart from Colin like to have a go at that?
I think for legacy aircraft, you've got a lot of very skilled people required to make a number of the parts. During the pandemic period, there was obviously a bit of flexing of organisations to reshape in relation to sort of demand, and the ability to ramp up and around some of those skill parts is going to be an issue. Where people can automate, it's great to be able to move to that, but some processes don't really sort of lend themselves to automation. It's going to be a different case for the next generation platforms. So there's that. I guess the money to invest and support the ramp up is another thing that sort of sits within the sector. Where we can help with a technology perspective, we will, and we're certainly keen to support more investment in technology in the near term. But it's where those sort of cases and opportunities exist.
Okay. I mean, just picking up on the point there about hidden costs of additive manufacturing that Colin mentioned. We've got here one of the greatest challenges in adopting digital manufacturing technologies has seen project costs of sort of inch ahead of lack of expertise. So anyone like to kind of take a deeper dive into that and just sort of explain, where are these hidden costs? Why is people worried about project costs?
Yeah, I would comment on that, if I may. So basically, I would start with the fact that I would just extend Colin's and Alex's comments with regards to the actual processes of additive manufacturing. So, of course, companies like Airbus, Boeing, and so on, before you utilize fully the additive manufacturing, you cannot really invest fully on in-house equipment in order to make all these parts that you need. So you would need to source them externally first, just to see the process flow, the results before the materials behavior, just to do an overall summary and evaluation of the product before moving forward. And of course, this does need time. The hidden costs, of course, because there are some processes like the metal printing in DMLS, for example, where we have support structures still. So this would need labor, it would need extra processes, which would require time until we have the final product. And of course, this could play a role on the consistency of the production of the parts, on the quality perspective, on the accuracy, on the overall timeline that would be needed in order to get the product ready. So all these factors would really need to be further improved or be able to focus on in order to, in a way, control better the project costs, or generally all the costs involved all around that area. And of course, this would need some time. It's good that we theoretically know how to approach this area, but it does need a bit of work to further to be able to be more confident and give a certain timeline about whether this could work definitely well.
Okay, Everin and Alex, are you any thoughts that on project costs kind of inching up there slowly on people's concerns?
Yeah, I can go next.
Go on.
Okay. So project costs is always, I think, a barrier, like the cost of adopting new technologies. And also in digital manufacturing, generally, it's always thought that they're expensive, very expensive to start with, because people don't know where to start with. So I think it's very well connected to the second challenge as well, which is a lack of expertise. For example, if we take additive manufacturing as an example, the digital manufacturing can be like can be seen in process monitoring and control for AM processes. And generally, these are expensive to invest because you don't know what you will do with the data that you create. So how you will use it, how you will utilize it. So that's why I think it's not just like a challenge on its own, but it's more connected to the second challenge, which is the lack of expertise in that field. If people know what sensors or what digital manufacturing technologies they need, I think the project costs will not be seen as the main barrier. I think it's very much related to the lack of expertise challenge.
Okay. Alex, you had a point as well?
Yeah, just to maybe add to that is, it depends very much on the area of technology that people are developing. So one thing we've certainly observed with a huge amount of excitement and demand around the new opportunities for zero emission aircraft is that people are moving into topics like hydrogen. Actually, the establishment of the knowledge, capabilities, skills is that people are planning programs and looking at them. But as they learn more, they actually realise actually some of the costs there are more than they would have expected. So part of it is recognising there's limited infrastructure capability around some of these things, and so some of the costs are higher than I guess would have originally predicted for some technologies that people are more familiar with. So it does very much depend on the area of technology. We're also seeing some things are getting very complex as part of meeting need for much more lighter weight integrated structures, meeting the rate requirements, and some of those again pushing the costs of some of the projects up. But the level of ambition is also quite high. So in some cases is the project ambitious enough, and sometimes that's going to require more investment to take technology, say, through to TRL 6 and recognizing all of the qualification certification costs. So one thing to consider is actually how do companies start working together to split the costs and get these technologies matured, where they're not trying to own the IP themselves, but recognizing this is kind of capability needed for the sector. So there may be different ways of tackling some of these costs, to get the needs. There also might be more effective ways of doing some of them rather than doing all in-house, working with RTOs or partners that have some of that capability that might help accelerate, reduce the cost of some of the projects. So some of it might be working differently too.
Okay, we've got questions that start coming in thick and fast now. Here, I just remind everyone just put them in the Q&A slot rather than the chat. Talk amongst yourselves, and Q&A, and then that flags it up. So here's a question from the audience: are there standard processes which can be used to verify prototype parts for flight, and if so, how mature are they? So there's a certification standards question. How far away from how mature are those flight ready, flight critical components from additive manufacturing?
Well, I think this, going back to the point I raised about the additive manufacturing community of practice, is that those standards don't just sit on the shelf ready to go. No one's in a rush to go and pay for them either, but they are needed. So this is about how you convene the sector to say, how are we going to go and make this happen? What are the key things we need to do? And what timeline do we need to do these such that they're there ready to support the opportunities where AM, can be certified onto future aircraft? Because how much is likely to go on a legacy is maybe questionable. The benefits of AM, it's where it's designed for the process, and you're making use of that with a new product opportunity. So they're not there yet, but it is in discussion about, well, how do we get them there, and who's going to be part of helping make that happen, working with standards bodies to do that, because they're clearly a critical part of the process.
I think
maybe I can add on that, Tim. Sorry.
Sure, yeah.
Yeah, I was just going to say there are some standards already published from ASCM on the qualification principles, but they're not like standards. They're more like guidelines or principles that are like recommendations. So although we have some standards published, it was from last year, they're not mature enough to follow them and just do the qualification as the guidelines say. So yes, we have still some way to go, but I think there are many efforts done in that field to have standards for qualification for additive manufacturing, especially metallic additive manufacturing.
Okay.
Can I just add to that from an OEM point of view? I mean, we can fly AM parts today, but generally we need a part qualification process, not a process qualification. So each of the parts we manufacture, we would need to do some level of associated testing with some test pieces that were within the build, so we can test the either structural performance of that part, so we understand. Then that becomes quite expensive. So the real route to seeing this going, mainstream is process qualification. Once we can get to that, and I get, and it's back to there's so many little elements of the process that you can change that would change the structure of the part. That from the size of if you're using a powder bed process, the size of the particles, the purity of the raw materials going in on some of the wire feed processes, all absolutely critical to the part. In subtractive machining processes, you get a billet which is standard and qualified, and then you just remove the material. You know exactly what you've got. You don't have that in AM today. So yeah, a real challenge.
Excellent. Okay.
So maybe
on to the next. Oh, sorry, Alex, you got a comment?
There's some great work that's going on to identify all of the key input variables and their impact on the outputs, to then work out, but via digital twin, how can you ensure that you've got a good part at the end as part of that sort of process control. So there is work that's going on that's planned around that would help get us there. But again, industry is a key part of helping shape that to make sure it is something that they could rely on that as a means of qualifying parts without having to do a part qualification in every case.
Okay. Next question here is how much manufacturing is produced in-house? I think, Alex, you mentioned in-house manufacturing. So this has dropped 10% from the previous year, which seems to contrast with larger insourcing trends? I mean, you think of Boeing and Spirit, people pulling in things and doing things more in-house to get more control, cost control, etc., etc. Do the panel have any thoughts on this as to continued outsourcing?
Yeah, I could start with that.
Yeah, okay.
So Colin, I would just comment on the fact that as a digital manufacturer, about how the collaboration between an XY company would be with digital manufacturers in order to save time and costs before investing on something doing in-house. Because, for example, manufacturing expertise or design expertise could be shared in order to further improve the process, bring the part and the product to market even faster. But of course, this would be something that, as I mentioned earlier, about preparing a part or highlighting or getting to a specific manufacturing process of additive manufacturing before trialing the actual parts. So for example, we can shorten the list of an XY process that could be used in additive manufacturing instead of just starting from scratch, let's say, and then we would be able to focus on and finalize the material and the actual process itself. And then the actual manufacturer, let's say Airbus, could be able to focus on some other parameters to bring this product to life.
I think from an Airbus point of view, I don't think we see or foresee a change in the make and buy split within the organization. I think what you will see is us getting a little bit better understanding of what things we do put out in the supply chain and having a level of intelligent customer. Right. Some knowledge around what we're putting in the supply chain, so we keep control of that and maybe help the supplier when they do have problems with supplying or where they have technical solutions. We're definitely not bringing all the parts in, because then that would limit our ability to have the global view on the innovation that they could bring to those parts that they're manufacturing. So I think we'll see maybe the growth in reference lines within the company. So we'll make some, but we won't make all, and then we'll second source that out into the global market to get the best benefits for everybody. Airbus would never have a model that everything was manufactured internally. Just wouldn't work as a global company.
Sure. So we're getting more interesting questions coming through here. So I'm going to take a pick here at one of them. Any plans for biocomposites, especially plant-based composite materials, at least for the internal structural components? Sustainability becoming concerning issue. Wow. Biocomposites go back to wooden aeroplanes. Anyone working on that? Do we know?
There are applications to the ATI program in that field. We recognise that there needs to be support for a more sustainable future. I mean, there's a lot of drive, obviously, in making lighter weight, more efficient aircraft. So it puts less demand on the propulsion systems. Whatever form they are, obviously, it reduces the energy demand to fly future aircraft. But in order to be sustainable, you need to consider how they're made, the energy in making them, their operational life and end of life. We do support it. Just being clear in terms of what's the technology that needs to be developed from an ATI program perspective, but there is development in that area, and we're happy to support more if people have got innovation in that space. At the moment, the key driver around the composites is being able to make these very complex integrated structure to the kind of quality that the OEMs expect at very, very high rates and at the right price. So there's an awful lot of technology development in that. the material that could go into them come from a number of sources. There is also, it's fair to say, an opportunity for the UK to start, manufacturing materials. It'd be, the carbon fibre and the resins. So not just doing the R&D, but potentially producing the materials here reduces potentially the carbon footprint around importing materials, and opportunity for the UK to capture more of the overall value associated with the aircraft. So not just producing the parts, but potentially reducing the materials that are going into them, and maybe having a circular economy where we deal with the material at end of life as well, whether that be going back into the aerospace sector or joining up with other sectors that might use that material.
Fantastic. Okay. Biocomposites. So another question we've got here, an interesting result from the 2024 survey that at least made me raise my eyebrows, was we had 34% saying their business was under 25% automated, 26% saying none at all, which has there been a rapid deindustrialization over the past year? What might explain this? Anyone got any thoughts on that as to what might on those results?
I can give you an Airbus view on our approach to automation. We think automation for the future is really important. We want to have operator-centric build processes within the organization. So if we can help the operators with poor ergonomics, dirty, dangerous processes, then we'll use automation. So there's a big drive within the company to develop the internal capability for automation. And that includes making robots and making end effectors within the company. Again, just so that we're able to then manage the supply chain, because historically we've gone out to the suppliers with a very basic functional specification and said, can you make us something that does that? And then we get something that could be implemented and could possibly be problematic during a ramp up phase. So I think we definitely have an approach which is not to replace everybody, clearly, but is to help our organization to grow in the right way, improve the quality, help with ergonomics, and avoid those dull, dirty, and dangerous operations for the future. Okay.
And we had a question here. I'm going to merge it into a larger one as well. Is a question I've already got there about AI and what do the panel think about the possibilities from AI? And Colin, you mentioned it's obviously robotics a little bit there, but the potential there for AI in advanced manufacturing, additive manufacturing, but also robotic manufacturing. One of the things I've noticed in the past 12 months that are now companies and tech firms who want to merge ChatGPT style natural language AI systems with humanoid robots. So are these going to have a place in aerospace manufacturing, or is it just a fad and they're just perhaps applicable for other sectors? What do we think about AI and how that might impact manufacturing?
I think AI is super exciting. Having done some very low level of exploration on some of the creative stuff, it is super interesting. I think the important thing is when we're building aircraft and when of utmost importance is the safety and quality and the passenger experience of those. We need to understand what the outcome is and what AI might be telling us, and make sure we're intelligent about that and don't just trust what an output would be. But so I think there definitely will be a growth in that, and we've seen some quite startling results coming out of some of these tools that are out there. I don't think we'll see humanoid robots, working with the co-working with our skilled workers, very soon. Certainly not even in the next program, not next decade, but maybe beyond that. Yeah, for sure. Why not?
Okay. And anybody else like to chip in with that?
Yeah, I would like to say a few words on additive manufacturing using AI. So I think AI is already there for additive manufacturing at research level, for example, to rapidly optimize the topologies or develop new process parameters, or for image processing for process monitoring purposes. But these are mainly limited to more use of traditional artificial intelligence, such as like machine learning based on a training data. But I'm more curious to see how this new generation AI, the new generative AI and AM can merge. Because with generative AI, I mean like the artificial intelligence that can create content. So that will be a very exciting and interesting combination, I would say. But still, there are some challenges with AI, especially the robustness of the AI algorithms we use, or the data quality, the availability, and interpreting the outputs coming from AI. So there are still some challenges to be addressed, but I also agree that it's super exciting.
Okay. So anybody else on that, Alex or Tassos?
Yeah, I would only say that apart from the fact that it's super exciting and really promising, I would say that it has to be used wisely and to the right direction in order to get the best out of it. Because I believe that apart from the hype, I think we need to focus mostly on the full utilization, the best possible utilization of it, and identify the areas of risk and the areas of that need to be improved and focused on aerospace industry in the best possible way. So I believe it's super exciting, but it's also super early to get any solid feedback on that.
So we're not quite there yet in asking ChatGPT to design an undercarriage and leaving it to run overnight and coming back in the morning and you've got a nice undercarriage done. So we've got a question here on, and again we're going to merge to the sort of audience question on. Given Boeing door quality issues, have there been any additional actions around supplier control of manufacturing and verification? And this ties in a question I've got as well. Focus on Boeing production quality issues, and also we had the fake parts story in the aerospace supply chain in the past 12 months. So these are both sort of safety related. Do the panel now think there's this fresh focus on manufacturing, certification, digital tracking parts and components? In essence, is this accelerated the push to digital twins, perhaps in a way that now people are looking? Here's a big safety issue. It's not with the pilots. It's not with the flight deck. It's actually with the supply chain, and it's with the production. So what do we think from that? Anyone dare comment?
Me? Shall I go? I just think we must not be complacent. We have the procedures and processes in place. They're really robust. Any shortcutting is totally unacceptable. We do closely monitor our suppliers and our own internal processes. It's unfortunate, what's happened to Boeing. It's not helped the industry in general. It has brought more focus on everything everyone does, and I think we've gone back in and reviewed our processes, and pretty confident, very confident that we've got the right mechanisms in place to ensure we produce a good product. Can't be complacent, particularly in ramp up environments, which we're all in at the moment. That's when these things can happen. So we just need to be really vigilant on maintaining processes and procedures going forward.
Okay,
the OEM perspective.
Okay, so unless anyone wants to jump in on that one as well, I've got a question. We've been mostly focused on the civil side of the supply chain, civil aerospace, but I've got a question here. So additive manufacturing defence. Now, obviously, we've seen things like 3D printed drones, 3D printed munitions happening in Ukraine. And one of the things that probably occurs to people is about, there's a need now to sort of scale up production or kind of supply chains of ammunition, of arms, of military technology. So, and also dispersing the supply chain. So maybe there's an opportunity there for people are now looking at vulnerability of kind of the industry supply chain and the kind of industrial footprint there. So maybe there's an opportunity there for if you think back into history of how shadow factories in the 1930s and people making sort of Spitfire parts in cottages. I mean, do the panel think there? There's a place for additive manufacturing there in addressing this challenge on the defence side of things?
And the ATI is funding civil aerospace technology development. You have to recognise that both civil and defence are developing technologies, might be for obviously clearly different applications, but the technology itself and be exactly the same in a number of situations, referred to as dual use technology. Does it make sense to work together? Because effectively, whether it's a defence or a civil organisation, often using the same supply chain. So working out what the sectors need and coordinating some of that engagement development makes a lot of sense. And it's not just limited to defence. There's a number of sectors where similar requirements it exists, so working effectively together really does make sense, and where HPMC and academia are often doing this. It's just being clear where there are I guess alignment in terms of materials and processes, and it makes sense to do that, but it's also is really dependent on those organizations wanting to work with the civil community. They've got their own funding streams, they can go off and do their own thing. So there's interest in getting that to work together. It's more effective support. Obviously, a lot of the defence work is funded by government. If the government can invest less and get benefit in multiple sectors, it could be interested in that. But the civil needs to be really clear on what it needs, and we're there to support that. And where it makes sense to work together, we should do. But certainly, demands on the supply chain, making sure they're robust enough, is key. And a number of those supply chain organisations are recognising that they need to diversify, because the impact of COVID on defence was clearly different from the civil sector. Civil's actually bouncing back now. And it's recognised, where those revenue streams are, but the similar capabilities required by both sectors.
Okay. Right. Okay. If no one else has got a comment on that, so we're coming up to almost coming up to running out of time here. So I'm going to go quickly. Final sort of couple of questions before we kind of go to a summary. So, do the panel agree on the where they see the aerospace focus for the next 3 years? So there was new technologies that kind of moved ahead slightly. Sustainability 2. Recruiting more skilled personnel, ramping up civil production has kind of dropped back. So now the demand is there. But do people agree with that broadly, or is there anything else we've missed, do you think?
If I start, maybe I think there's. Sorry. I think there's an awful lot of focus on the new technologies, and recognising this huge amount of opportunity with the next generation platforms, also including the eVTOL market, and the long term no zero emission aircraft and a lot of organisations now focus on getting those to happen. Also recognising there's a window to get those mature to TRL6 be positioned, that they can be designed into the next generation aircraft. Sustainability is clearly important. A number of those new technologies are associated with sustainability, but sustainability isn't necessarily embedded in all organisations to the same level. There's obviously a broad number of things that covers, and the standards are still, I think, developing. There's a learning curve that's going up there, but it will increase in importance over time as organisations kind of put metrics in the organisations, policies come into place from their organisations, but also from government. And we need to be sort of prepared, particularly things like the carbon border adjustment mechanism and other things that we need to make sure we've got sustainable processes. There's obviously a lot of focus on the energy associated, certainly the carbon and also non-CO2 associated with aircraft operations. But when you've addressed those, actually the manufacturing then becomes a bigger portion. So having lower energy and emissions associated with making the parts is something that you need to get in place now, so that we're also addressing that portion of the emissions too. And
what about everybody else then? Are they agreement of the than aerospace focus for the next 3 years, or?
Yeah, I think these three topics are most important ones. I'm actually a bit surprised to see that we didn't have new technologies last year as a result of this question. But yeah, new technologies, I think they also include not only manufacturing technologies, but also technologies to work on new materials and also digital technologies. So I think I think I would agree to that point that it's the most critical one as the next for the next 3 years.
Colin and Tassos, how about you?
Well, from an Airbus point of view, obviously we're spending a lot of effort right now in preparing the future. So getting our technologies in a good position, as Alex said, getting the maturity levels up in good time to help us make the right decisions on whichever next product we make, which will be in the next decade, towards the end of the next decade, I would think. Will be. So yeah, a lot of effort on those right now. Those topics are all key. When we do make that transition and do launch that program, the skills, so, having the right skills and the right volumes of skills and a stability in the supply chain will also be really important. So a lot of focus in the coming years.
And
from
Tassos,
my
would you
view,
agree with that?
to summarize, yes, I would definitely agree on that. And if I had to summarize it quickly, I would say just a combination of material science, additive manufacturing technologies to specify those, and design skill set as well. It's a combination and key considerations for the further improvement and the more stable future for aerospace in this moment.
Okay.
I want to add one sentence, Tim, maybe to this question. Looking at the results of this question and also the question on automation, I think most of the respondents were from research and development. That's why we have new technologies as the first thing here, and automation being less important in that question. So I guess it's very important to know which departments these people were working in, because it will change the results a little bit differently. But definitely new technologies are very important.
Fantastic. Okay, so we're coming up to the end of this now. Gosh, the questions coming flying in. We've got stuff about weightlessness. We've got more about the hype about AI. I'm just going to do one last quick fire question from me around the panel. What are you personally most excited about in terms of advanced manufacturing aerospace technology that's perhaps going to disrupt the sector? So, go. Who wants to go in? What's there? You thinking, wow, that's going to really change things, on the horizon?
I would say, as I mentioned before, the merge of AI, generative AI, and additive manufacturing seems to be the most exciting thing for me.
Yeah.
I would say Airbus have got some really exciting technologies they're looking at for the next product, but I can't tell you about them.
So that's a tease. Alex?
I think the next generation of materials and manufacturing processes that are going to make these lightweight structures. I mean, AM is part of it. Obviously, composites has a key role to play. It's a range of other sort of technologies like coatings and others that are really helping support the next sort of performance levels within engines. So I think there's a whole array of technologies. Seeing some of the significant step changes in sort of performance of lightweighting associated with some of those is key, but I just want to see them realize being in a position that they can get into the next program. So I certainly think AI is an interesting one to keep an eye on. Additive manufacturing, I think, is going to have a critical role to play, but it's right materials and process for the application. So it's about having a breadth of technologies that are there that the UK is leading in. So excited for a lot of developments, but wouldn't pick out anyone in particular at this point.
Tim, can I just add a quick?
Oh yeah, go.
Airbus on a serious note, it's going to be all about aircraft performance at the end of the day, the way the fuel costs are going, and what we have to do for safe and sustainable flight for the future. but we have to do that at the high rate and make it economical. So we have to find the low cost.
Sure. And Tassos?
Higher, much higher on the agenda for the future.
In short, I would say for me, the main drivers would be energy sources and resources, a combination with AE, AI, and design and material science. I think these are really related, but I would start as a number one. I would start with energy sources.
Okay. Fantastic. So I'm going to have to pull this to a close now, as we've just run out of time. I'm sorry if you haven't had your question answered. I'm looking at now that there's some great questions here. Where we could go on all afternoon. I think we just scratched the surface here. I think you'll all agree this has been a fascinating session and very insightful. I've certainly come away with my head brimming with ideas and knowledge, and I hope you have too. Any quick closing thoughts from the panel that they feel they didn't get addressed?
I think it was really well covered. I finish at Airbus in the next 2 weeks. I will still be available on the market. Find me on the usual sources.
Fantastic. So we'll look forward anyway to maybe bringing this back next year and seeing what the 2025 survey comes out and whether things have changed. I'd like to thank obviously Protolabs for partnering on this survey, and of course our expert panel for giving up their valuable time and contributing, and of course everybody here on the call as well for dialing in and your very valuable questions. In the meantime, I'd like to encourage you to check out the other RAeS events, both virtual and physical we have in the pipeline, such as Applied Aerodynamics Conference in July. We have the President's Conference Design, Build, Fly in October, AI and Civil Aviation in November. That's going to be a really one to watch if you're interested in AI. And also coming this month on 27th of June, a social function, Aero Society Lates, evening at RAeS HQ, where we're having a screening of Top Gun Maverick, followed by a Q&A with a real-life naval aviator. So grab your Ray-Bans and sunglasses and come down to watch that. And if you aren't a member, either individual or corporate, why not? So all the information's on our website. Get over there, have a look, and it's been brilliant. Thanks again for everybody here. Give our panel a big virtual round of applause, please, and thanks for taking part.